Buenos dias. It's great to see everyone here. This is an amazing conference on such an important topic that affects all of our lives, and as was said by Jose in the beginning, will affect our communities well into the future. The group we have on stage now reflects that 1%. Natalie said 99% of wastewater is water. Well, this group is really concerned about that 1% that's not pure water. And as described in the first session, our region has a really limited supply of water. And it doesn't matter if you're talking about a primary source of water or recycled water. Contamination of those water supplies with harmful chemicals or pathogenic microbes is a major burden for both human health and for agriculture. Like air and water, microbes and chemicals do not know borders. So it's really important that we continually monitor our water supplies to ensure that they're safe. Even with advanced technologies, things break down, and you have to have that constant monitoring to make sure that you have safe, clean, fresh water supplies. In addition, we really need continued research not only to develop better ways of purifying water, but to make sure that we can detect those breaks in water quality very quickly so that we can reduce the health risks that happen afterwards. Collaboration on these issues, as with every issue we've talked about today, binational problems require a binational solution. I think one of the first speakers gave us that quote. And I think it's a really important, good quote for us thinking about this big problem. I just want to add one other thing, and that is that one of the key things that's apparent today is how transdisciplinary the problem of water is. To solve this problem, we need people who care about social structures, who care about equity, about economic development, about engineering, and also about things like ecology and microbiology. So we'll hear some more about today. Our first speaker on this topic is Rick Gersberg. He's a professor in the School of Public Health here at SDSU. His research is focused on water quality, including both chemical and microbial contaminants and human risk assessment. Rick has for a long time studied issues of water quality in the Tijuana River and the estuary. He studied them in Salton Sea, and he's also played a real key role in understanding water quality in the Venice Lagoon in Italy. Rick.
Thank you very much, Stanley. It's very good to be here. I have worked a lot in Mexico and on the Tijuana River, but today I'll be talking about a different subject, namely the implications, health implications of the direct and indirect potable reuse of sewage, and also the city's Pure Water Project, the City of San Diego's Pure Water Project. I happen to be on their independent advisory panel, so I'm very familiar with that project, and I'll talk a bit about it as we move forward. As was said before, this project, Pure Water, which you might know as, not affectionately, but you might know as toilet to tap, has been percolating around for many years, but soon, very soon, it was supposedly by 2021, but now I think it's slipping a bit to 2023. They are already in construction with the first phase, so 30 million gallons of potable reuse of sewage basically will go online about 2023, and phase 2 by 2035, such that by 2035 about 35% of the city of San Diego's water will be from sewage origin. And we'll talk about the treatment and some of the health implications of a lot of different water conservation and reclamation projects. And down here is large-scale seawater desalination, like the Carlsbad plant. That comes in, and actually it comes in at $2,600 per acre foot. I'm not going to convert that to cubic meters, but most of you know what an acre foot is, 325,000 gallons. And this is indirect potable reuse, which I'll talk about, the city's pure water project. And that's coming in slightly short of $2,000. And so if we really compare the two, there isn't a huge difference between the cost of potable reuse of sewage and desalination. However, as I'll talk about, there's other really big advantages to doing potable reuse of sewage. One, it's, again, diversifying our supply. And, of course, we're always producing it, so it's sort of foolproof. We don't have to worry about importing water from anywhere. And two, I'll talk about it impacts our discharge of treated sewage, primary treated sewage from Point Loma. We've been told by environmental groups and by the EPA that that has to be cut down and cease unless the city of San Diego upgrades to secondary treatment, which costs billions of dollars. And so the plan is, because of that, also to move into indirect potable reuse. These are the reuse principles of California. I won't say too much about them, except the first bullet, pure, wholesome, potable, and healthful. We're already doing it. De facto reuse is occurring when, as mentioned, we drink the treated sewage into the Colorado River from Las Vegas and other cities. So we're already doing it to a certain extent. And conventional risk assessment has shown it is fairly safe, at least safer than what we're currently drinking. So I'm going to talk about two types of potable reuse. One is direct, which we're not doing yet in California or in San Diego, and the other is indirect. On the left side, direct is treating it very highly and then putting it right into the drinking water supply. Indirect is putting it into a reservoir or a groundwater basin for taking out eventually and then treating it later. This is not direct potable reuse. And again, we're not doing direct, and there's no immediate plans to do direct, but direct involves, again, treating it to advanced treatment standards and then putting it directly back in the drinking water treatment system. There is a bill, an assembly bill in California that sets a 2023 deadline for developing what's called direct potable augmentation regulations. That is, you treat it very highly and then put it right back into the drinking water system. But those regulations have not come out, and so what the city of San Diego's Pure Water is doing and others are indirect. Indirect, as we see, is treating it. Again, this is wastewater, treating it very highly, which I'll talk briefly about, and then putting it either in a reservoir or in a groundwater basin, and then taking it out and treating it again as drinking water. Orange County has been doing it many years. I have students from Orange County, and when I say that, many of them don't know that they've been drinking sewage, but hundreds of thousands of people in Orange County have been drinking it for 20, 30 years. So it's one of the oldest and most well-known projects. Again, in San Diego, we've been told, there was a lawsuit way back, there's a long history, that we have to stop putting primary treated water because the Clean Water Act says you have to treat it to secondary. And the EPA and other environmental groups have spurred the city to consider other ways of treating, other ways of taking the water without putting it into the ocean. And one of them, of course, is us drinking it. And so that was one of the reasons to move into the Pure Water project. I'm going to skip this in the interest of time. This is the treatment system I'll talk about very briefly. Again, we're doing primary treatment, secondary treatment, and tertiary treatment. And I'm not teaching a course on wastewater treatment, so I'm not going to explain what all those are. But tertiary treatment is purple pipe, so it's already fairly highly treated. So we can use it to irrigate ball fields and parks and golf courses. But we take that tertiary treated water, and then we're going to put it and treat it with ozone. Ozone does a variety of things, but it disinfects that water. Then it goes through activated charcoal, which many of you have, water filters. And this removes a lot of small organic molecules. Then it's going to go through a membrane filtration, very small pores, which removes pretty much all bacteria, particles, and most viruses. Then it goes through reverse osmosis, which is another membrane system, which pushes the water through the actual molecular structure of the membrane. And so only theoretically water molecules go through and everything stays back in a concentrate. We take that water that went through the membrane, everything else stayed behind. It then goes through a ultraviolet light with peroxide or with chlorine, and that's called advanced oxidation, which destroys most, if not all, organic matter. Then they chlorinate it in a pipeline. It goes into now Miramar Lake, which is near my house, and it's a very high quality water. Then it goes back to our current conventional drinking water treatment plant, and it's treated again for drinking. So you see, it's very highly treated. There's Miramar Reservoir. Here again is the system. These are the criteria by which California, the Division of Drinking Water, looks at the criteria for health. The first, it has to meet all the requirements for drinking, what's called maximum contaminant levels of the Safe Drinking Water Act. Secondly, it looks for control of all organic chemicals, including pharmaceuticals and drugs and emerging compounds. And the third bullet, it looks at a variety of treatment steps or multiple barriers to remove pathogens. And I'll talk a little about both organic contaminants and pathogens. We know that there's a lot of conventional contaminants, which we have a handle on, but there's a whole variety, hundreds or more, thousands perhaps, of what we call compounds of emerging concern. This includes estrogenic compounds, endocrine disruptors, pharmaceuticals and personal care products, antibiotics, drugs that people take, and many of these are excreted into wastewater. And of course, if we don't remove them, they'll get into our drinking water. So testing has been done by the City of San Diego's Pure Water Project on a variety of selected compounds which have a variety of chemical structures which perhaps mimic the structures of this larger set of compounds that are out there now. And these are just some of them. They include steroids, antimicrobials, painkillers or analgesics, psychoactives like carbamazepine, Xanax, tranquilizers, and things like that, and others. And this table shows the concentration in tertiary effluent. That's the effluent that will be going to the advanced treatment process. And then the concentration of a variety of these after reverse osmosis. And then the concentration after what's called advanced oxidation, which is sort of the final treatment step before it goes out in the reservoir. And you can see there's considerable levels of a variety of these compounds. These are in parts per trillion. Very few get through the reverse osmosis when it's being operated correctly and there's no leaks, although that can happen. And virtually nothing gets through the advanced oxidation. So it looks great so far. This is a little more of that. If we look on the right, more NDs, non-detects. That doesn't mean nothing is there. It means we can't detect it. But for our purposes, we'll say they're not there, these. The second requirement is to remove pathogens, bacteria, and viruses. And I don't want to go through this whole thing, but there's a new what's called surface water augmentation rule for indirect potable reuse. That is, if you're going to put it in a reservoir, you have to remove a certain value of pathogens, a certain removal. They call it log removal values. 1 log is, this is for those of you who aren't too technical, 1 log is 90% removal, 2 logs is 99%, 3 logs 99.9%, 4 logs 99.99. You get the picture. You don't want me to go on and on. They require, before putting it into a reservoir, for viruses, let's see where we go. Yeah, there we go. For viruses, a parasite called Giardia and Cryptosporidium, 8 logs, 99.99999, and 7 logs and 8 logs. And depending on the reservoir, the requirements for the City of San Diego's Pure Water Project is 10 logs for virus, 9 logs for Giardia, and 10 logs for Cryptosporidium. That's a lot of 9s. So, and then the water is going to be treated again as drinking water. This actually shows the removal that the city is actually getting, and you could see required here is 10, 9, 10. The city is actually getting 21 logs, 22 logs, 21 for virus, 22 for Giardia, and 14 logs for Cryptosporidium. So they're really way in excess of the requirement of the health department. So again, that looks very bright and healthful for the city's Pure Water Project. Okay, so the question is it absolutely safe? And let me say here that nothing is absolutely safe. Anything you do, particularly if it's desirable, has some level of risk. And I'm going to talk a little about this in the few minutes remaining. The City of San Diego's Pure Water Projects has measured hundreds of chemicals, including emerging chemicals that I've talked about, and it's looked at several pathogens, viruses, and parasites, 3 or 4. It spiked them in and looked at the removal. But we have to consider that there's about 60 to 80,000 chemicals out there in commercial use. So if the city and other water purveyors like Orange County have looked at 300 or 400, that's only a small suite of what's out there. There's also, according to this, about 219 species of viruses that can infect humans. Now, I'm not saying those are all in there, nor the chemicals are not being treated. But again, when it comes to absolute safety, if someone asks me, is there anything in there? Is it absolutely safe? While others might say it is, nothing comes with absolute guarantees these days. And I'll elucidate this. So there are things we don't know that we don't know. And of course, we don't know how they're going to appear. Prions, which cause that brain disease, is not a virus or a bacteria, but causes disease, was something we never could figure out. Vaping, I mean, what's happened with the recent vaping and the lung disease was something we really didn't expect. Those are called black swan scenarios. That's a black swan on the right. And we never know. Since unknowns are unknown, we can't anticipate these. one way to start to get a handle on the absolute safety, that is, not measuring things one after another until you've measured 80,000 chemicals and 220 viruses. That's not, you can't do that. But one way is to do an epidemiological study and follow people who are drinking reclaimed sewage. And that makes a lot of sense. I'm not sure most engineers think that that's a viable way to look at it, but from being that I'm from a school of public health, I think it makes a lot of sense. And it says here, surprisingly, to date, there has only been a single epidemiological study on a population in California, or really anywhere, that's drinking reclaimed sewage. And that was, I guess you can see, there's a lot of numbers here. But that was the study in Los Angeles on what was called the Whittier Narrows Project. They weren't treating the water quite as highly as the city of San Diego does, but it's the only study. And they found mostly, they looked at both infectious disease, and this is cancer. These are sites on the left, are all the cancer sites they looked at. And for the most part, they didn't find any risk. These in red are where they found elevated risk. And they looked at 900,000 people, so it was a fairly large epidemiological study. And they broke up the groups to people drinking very small amounts of water, a little more, moderate amounts, and the most amount of reclaimed water. That was the exposure part of this. And they did find, in the case of liver cancer, that those drinking the highest amount of reclaimed had an elevated risk. Now, epidemiological studies have their problems. You all know there's been studies, let's say, on coffee. Some studies say this coffee is bad and it does all kinds of things. There was talk that it caused cancer, although I don't believe coffee or caffeine does. Others say it's really good for you. You should drink 6 cups a day. I mean, it's the same with alcohol. So one epi study, you really, it's indicative, but you can't go on. But as you start to do more, like with smoking, we begin to see the trend. And as I move to the end and summarize, well, I'll talk about epi studies at the end, but I think as we move, the state of California, it's been mentioned that there's 6, 7 projects in the region that are going to be doing indirect or eventually direct potable reuse. I think the state needs to really look at it and say, we have to start doing an epidemiological study to look at absolute risk. So in summary, potable reuse is viable. It's the first bullet. There are many unknowns. So we cannot, or I cannot, say, if someone asks me, is it absolutely safe? I can't say it is. It's safer than the drinking water we're drinking now, most probably, but nothing comes without risk. All studies on pure water to date have shown, as I said, that it's better than what we're currently drinking. And as I said, I think as we move forward in California, this is going to be more and more frequent, that is indirect or direct potable. We need to do epidemiological studies of people drinking the water to see really whether it's absolutely safe. Thank you very much.